Welcome to Culture, Worldview, and Origins. We're Tim and Holly Nyquist. We're in this series on critical thinking skills in science. This is chapter 13. We're looking at Thomas Kuhn's essay on critical thinking. Well, not critical thinking, but it is on science, and it's being kind of critical of how science is done. And science is about getting to reliable knowledge. And so this is kind of fitting into this whole chapter, bringing it to a culmination of how do we get to reliable knowledge through science. This is session number 2. We're looking at chapter 2, and the title of it is The Route to Normal Science. And so what is normal science? So this is what we're going to define normal science, and this is what the whole chapter is on normal science. Before, the previous chapter was on history, and how history did not appear to be continuous or sequential, linear, but that it went in blocks, in paradigm change blocks. Okay, so the definition of normal science, what he means, research firmly based upon one or more past scientific achievements that some particular scientific community acknowledges for a time as supplying the foundation for its further practice. Okay, so normal science means that this is the science that is being practiced presently. And it's being, according to this paradigm, according to these theories and rules, because of previous experiments, because of previous scientific achievements, that they have adopted this way of doing it. And so this is what normal science is about, the science that is being practiced at this time because of certain achievements. He goes on to say, today such achievements are recounted, though seldom in their original form, by science textbooks, elementary and advanced. These textbooks expound the body of accepted theory, illustrate many or all of its successful applications, and compare these applications with exemplary observations and experiments. They were able to do so because they shared two essential characteristics. Their achievement was sufficiently unprecedented to attract an enduring group of adherents away from a competing model of scientific activity. Simultaneously, it was sufficiently open-ended to leave all sorts of problems for the redefined group of practitioners to resolve. So what we have here is normal science is now practicing according to a standard, and that is a new standard. That standard now has attracted adherents from the old standard, and they have come over to support the new standard, the new normal science. And so this is what it means, that it produces an enduring group that will now practice according to its vision, according to its parameters. Endure a group from competing models of scientific simultaneous. So there's two things. One is that their achievement was sufficiently unprecedented to attract. Number two, it was sufficiently open-ended to leave problems for scientists to solve. So it attracted scientists because it solved some big problems, but it also left now new open problems for them to solve. So it was attractive in two ways to them. Achievements that share these two characteristics, I shall henceforth refer to as paradigms, a term that relates closely to normal science. Now, Kuhn is just introducing his term paradigm and what he means by it. And it's kind of throughout his work, paradigm has shifted to mean a couple different things in different contexts. So this is the original base meaning of paradigm. So in other words, when there is enough achievements that support a new way of looking at something, and there are enough undone or still problems to solve that attracts the scientific community, then Kuhn calls that a paradigm. A paradigm that it has within it, it's packed in with a lot of factors, which he doesn't enumerate really, but the paradigm is what now rules and moves what's called normal science. Men whose research is based on shared paradigms are committed to the same rules and standards for scientific practice. That commitment and the apparent consensus it produces are prerequisites for normal science, i.e., for the genesis and continuation of a particular research tradition. Okay, so in other words, the men that join this group, this new paradigm, are committed to practicing this new paradigm according to the same rules and standards. So in other words, they've committed, they've signed on the dotted line. As member of this group, you are committed to. And what's interesting is that, and Kuhn will go on, is that those rules are never really defined. And most scientists study paradigms, but not necessarily the rules of those paradigms. And so when asked what the rules are, they may not even be able to verbalize what the rules specifically are, but they know what the paradigm allows. That commitment and the apparent consensus it produces are prerequisites for normal science, the genesis and continuation of a particular research tradition. Okay, a particular research tradition, which means traditions can change. And that's what the early Greek philosophers were doing, is that they said, we're no longer following authority, we're no longer following religious parameters, we're no longer following traditions. And so they started off in their own angle. And so this is what this explanation is. Normal science is a continuation of a particular research tradition. It's the way we've done it. It's the way we do it. And if you're going to be a part of the scientific community, then you must ascribe to the same rules and practice. No period between remote antiquity and the end of the 7th century exhibited a single generally accepted view about the nature of light. And what we're going to go through is a few samples here of problems in the early antiquity, of which they had men studying them, but there was no consensus. There was no consensus on the rules. There was no consensus on the metaphysics of defining reality. What is it? And so it says there was no period between remote antiquity and the end of the 7th century exhibited a single generally accepted view about the nature of light. Instead, there were a number of competing schools and sub-schools, most of them espousing one variant or another, Epicurean, Aristotelian, or Platonic theory. So in other words, those were competing philosophers that had their own schools, and those schools were competing with each other about what was reality, what was the real world like. And so each school had their own vision of what they were studying and what were the parameters for its studying. And so it says no period had a consensus. It had no single generally accepted view about the nature of light. Yet, everyone examining a survey of physical optics before Newton may well conclude that though the field's practitioners were scientists, the net result of their activity was something less than science. Okay, so all the way up to the time of Newton, we're talking about optics. So we're talking about light. We're talking about what was the initial parameter or question of the different philosophical schools were defining what is light. How does it work? How do we perceive it? And so it says, yet anyone examining a survey of physical optics before Newton may well conclude that though the field's practitioners were scientists, okay, I would say they probably didn't carry the label scientist, because the label scientist was actually invented in the mid-1800s, 1850 something. Before that, they were called naturalists. And that's why Charles Darwin was not a scientist, he was a naturalist, because the term scientist actually did not exist. They were called, like I said, they studied nature, they were called naturalists. And so here they were scientists, they were naturalists, and they studied things very methodically and according to maybe even what would be considered the scientific method. But the net result of their activity was something less than science. It was something less than what we would consider today as science. It would either be a pseudoscience, it would be error, or it would be superstition, or it would be myth. It could fall into those categories. But we have that same thing today. And we've talked about knowledge and how knowledge has an expiration date today because of technology, because of the advancements. In the medical field, knowledge has an expiration date of between 17 months to 3 years, but we don't call it myth, or we don't call it even error. We call it, it was science of that time period. During that period, the early 1800s, there were almost as many views about the nature of electricity. So now we're on to another term. We're moving from optics and light, we're moving to another category of what's called electricity. And what was it? During that period, early 1800s, there were almost as many views about the nature of electricity as there were important electrical experimenters. Men like Hawksby, Gray, Desaguliers, Dufay, Nollet, Watson, Franklin, and others. They all had a different perspective. They were practicing science according to the parameters of their day, and these are all renowned names, but yet they were practicing it not in a way that was concerted, that were under, they each had a view of what was electricity. It says both fact collection, okay, fact collection. There's data collection, and then there's fact collection, and fact collection is the process or the result of a theory applied to data. So both fact collection and theory articulation became highly directed activities. Okay, highly directed. So in other words, if they're doing it, there's maybe one theory, and that theory determines what a fact is, or how to interpret the data to become a fact. The effectiveness and efficiency of electrical research increased accordingly. Because there was a united way of looking at it. It was defined. What is electricity? How do we study it? What are the parameters of it? And so it was becoming defined, and by becoming highly directed and defined, the effectiveness and efficiency of electrical research increased accordingly, providing evidence for a societal version of Francis Bacon's acute methodological dictum. Truth emerges more readily from error than from confusion. Okay, so we have all these scientists or naturalists that are studying the scientific world, the natural world, but yet if they aren't on the same page about their view of metaphysics and what is real and what is not, and their theories about things, if they're not on the same page, then they're coming at things very differently, and they can't even communicate with each other. They're incommensurable, their products, because they are produced by different paradigms, different views of nature. But once you come down to one view, then you can discuss, debate, and you can progress a lot further. And this is the dictum, is that truth emerges more readily from error. So in other words, if you're on the same page, then truth will come out, even though you're committing errors. The errors then will line up eventually with the theory. And the theory will define then the errors and redefine it till it becomes fact or truth. Truth emerges more readily from error than from confusion. So in other words, confusion means that this guy's saying that guy's saying that, this guy, they're all saying different things. And so it's like a Tower of Babel where you've got confusion. Everybody is talking, but nobody is communicating, and they don't understand each other. And so Bacon's methodological dictum is truth comes more readily from error than it does from confusion. So if we get on the same page, we're going to get there eventually. We shall be examining the nature of this highly directed or paradigm-based research in the next section. Okay, so once we come down to narrowing the rules, the theories, and what to expect and the metaphysics, then we enter into what would be a paradigm, a central paradigm of which everyone then is practicing as from the same paradigm. We shall be examining the nature of this highly directed or paradigm-based research in the next section, next chapter. But must first note briefly how the emergence of a paradigm affects the structure of the group that practices the field. So a paradigm affects the structure of the group that is practicing. How? It organizes them. It puts them into line. It puts them into one thinking process that then they all have the same goal, starting from the same point of understanding, from the same perspective. Now they can all look towards the same goal. Instead of looking at each other and debating, now they can focus forward on with the same motives and the same direction with the same definition of terms. So that is how a paradigm then influences a group, is by structuring it. The new paradigm implies a new and more rigid definition of the field. Those unwilling or unable to accommodate their work to it must proceed in isolation or attach themselves to some other group. Okay, before we had a number of electricians that are working on this problem, and they're all electricians, they're all scientists, they're all naturalists, they're all working in competing schools. But now once a paradigm is accepted and that there's more scientists that jump on board with that paradigm, if a scientist does not jump on board with that new paradigm, and then he remains or becomes isolated, and his work is isolated, and he either has to attach himself to somebody else, to some other group, or just fade out of the picture, because he's not going to be able to compete with the community, with the group, the scientific community that is all functioning under the same paradigm. So what happens when a paradigm comes through? A paradigm, you either jump on board or you get out of the way. If you're on ascribing to a different paradigm, and then this other there's two paradigms that are close, they're almost competitive, and one of them is growing and the other one's receding, that difference is going to become more rapidly separation. And if you don't abandon the old one to get on the new one, then you're going to be left out of the field of study. You will no longer be possibly considered then a scientist or a naturalist, and your work would not be regarded. Ever since prehistoric antiquity, one field of study after another has crossed the divide between what the historian might call its prehistory as a science and its history proper. So in other words, it's saying that every field of science has gone through a transition period of where it was a prehistory, where it had a lot of advocates that were advocating something different, and there was confusion in the field. But eventually there was one assumed paradigm that all the scientists one by one eventually got on board with, and the one that was that is what can be seen in most history of the development of different fields of science. And so he calls this the divide between what the historian might call its prehistory as a science and its history proper. This brings to an interesting question for today, because we're talking about history, prehistory. Maybe prehistoric, but it's talking about prehistory means before it was considered science. And what is the demarcation? What is the line to consider something science or not science? And that's what we had found before in a previous study under worldview. We're talking about truth, or we're talking about what is science. And Milton D. Honnox, he affirms what is science. He says, questions for which there are no generally agreed upon answers or ways of getting them are taken to be philosophical questions. That is why science is a fairly new term in the last 150 years. So in the 1800s, early 1800s, even up to Charles Darwin's time, they weren't scientists, they were naturalists. They worked under philosophy as philosophical naturalism. So they worked as philosophers, but they were called naturalists, and so they worked as a branch of philosophy. There was not a separate branch of science at that time. So what Honnox is saying is that questions for which there are no generally agreed upon answers or ways of getting them are philosophical questions. And so that is what the field that has multiple voices that represent different lines of thinking. Each line of thinking represents a different philosophical tradition. And he mentioned whether it be Platonic or Aristotelian or whatever, is that those different traditions philosophically, as long as there exist different traditions philosophically, that is not science. Those are philosophical questions. Is not science. And he goes on to say, questions for which there are in principle definite answers or agreed upon ways of getting them are taken to be scientific questions. So today, is this a philosophical question or a scientific question? Well, that depends on, is there only one right answer? Is there only one right way to get to that answer? Then that's a scientific question. If there are different schools, philosophical schools addressing that question, then the question is not scientific. Then the question is philosophical, according to Milton D. Honnox, that is how we can differentiate between something being pre-science, in other words, it's philosophical, or scientific. Well, now it's separated from philosophy, and there's only one philosophical current that has been now accepted, and that is the only acceptable way of getting to the answer. If there's only one right answer and only one way to get to that answer, that is a scientific inquiry then, and that is a scientific question. If there are multiple ways to get to that question, answer that question, and there's multiple people vying for that answer, then that is a philosophical question according to Milton D. Honnox. We're on chapter 2, session 2. Chapter 13, we're looking at Thomas Kuhn and his approach to critical thinking and his critical thinking about science. Thank you again for joining us. We're Tim and Holly Nyquist, and if you'd like to communicate with us, the addresses are here on the board. Thank you again.